Welcome to our final note-taking session for Unit 4. This is Topic 8, People and Machines. As I go through this, you're going to see highlighted text. That's the text that we're focusing on in most cases. If there's no highlighted text, it means we're focusing on all of the text on those particular pages. All right, so if you feel it easier, you can print off the pages and fill in as we go, pausing as you need, or you can modify the Google Doc as if that's easier for you or if you prefer it that way. Either way is great. All right, starting on. As you read through this topic, think about how the development of machines throughout history has brought pleasure and comfort to societies. Think also of the negative side. What kinds of problems and challenges do these technologies bring as well? How are we trying to meet these challenges? What types of choices must we make? What do we need to learn from past experience in order to make the future better? The Industrial Revolution. The invention of the steam engine transformed society. No one can say for certain when the Industrial Revolution began. Simple machinery had been taking the place of hand labor since 1700. The water-driven spinning machine, introduced in 1769, for example, could do the work of 12 workers. A combination of events in the late 1700s, however, transformed England and the world. First came James Watt's invention of an efficient steam engine in 1769. A year later, Henry Cort developed a method of making iron using coal for fuel instead of wood. The iron to build machines and the engines to drive them led to the rapid development of mass production industry. Mass production is the manufacturing of large quantities of a standardized item by standardizing mechanical processes. Modern examples include the manufacture of home appliances in a factory, the canning of foods in a food processing plant, and the production of automobiles in an assembly plant. Within a few years, small towns such as Manchester and Birmingham in England became industrialized cities teeming with factories. And industrialization led to great societal change. Unable to compete with the new factories, the spinners, weavers, and craftspeople from the villages flocked to the cities to find work. The transformation from a rural to an urban society had begun. Which came first? The question of whether the needs or the wants of society results in new technology or whether new technology changes society continues to challenge us. It is sometimes said, for example, that the oil industry is so large because of the demand for fuel to run automobiles. However, some people say that the reason we have so many cars and use them so often is because of the low price and abundance of gasoline. We can build large cities because it is possible to get around in them so easily using automobiles. Even in our largest cities, people travel from one end to the other to get to work and back home again. 100 years ago, it would have taken half a day to make the trip one way. Do you think cities are so large because we have vehicles, or do you think we have vehicles because our cities are so large? All the vehicles in figure 4.67 were popular at a time when people thought fuel was unlimited and that the atmosphere could absorb all the pollutants entering it from the industry and car exhausts. In the 1700s, scientists began to inform people about a shortage of fuel and the negative environmental effects of fuel combustion. As a result, many people's attitudes changed, and so did their choice of vehicles. Look at the newer models of vehicles in figure 4.68. What are the obvious differences between the older models in figure 4.67 and these newer models? Like the aircraft you studied in topic 7, and the cars you have examined here, vehicles are constantly being improved as experimental designs are tested. The vehicles in 4.69 are alternatives to gasoline power powered gasoline-powered vehicles. The racing car in figure 4.69a uses solar panels to capture the energy of the sun. Solar energy is stored in a battery in the car. The van in figure 4.69b is powered by electricity. Most electrically powered vehicles can travel about 80 kilometers before the battery needs recharging. The bus in figure 4.69c is fueled by a hydrogen fuel cell. This cell fuels a chemical reaction that uses hydrogen and oxygen from the atmosphere to make electricity. The only exhaust from this bus is water that is clean enough to drink. Why do you think these vehicles are not widely used? Just have a quick look at those vehicles. All right, what is it for? This is on page 346. Sometimes scientists have to ask themselves difficult questions. They often have to weigh the positive and negative effects of a technology or a new discovery. We may have the scientific understanding and technological know-how to design something, but should we do it? For example, many people feel that we should not use nuclear power to generate electricity, even though we know how to make and use this form of energy. While this technology is actually quite clean and causes little pollution, when it is working properly, accidents at nuclear power generating plants can have devastating effects on both society and the environment. There are times when you need to answer questions responsibly and consider how your choices might affect society or the environment. You often do this when you purchase something. Do you own an item that features much more technology than you will ever need? Do you ever consider the energy required to make something that you own? What kinds of materials were used to make this product? Where did these materials come from? And does the product generate any waste? Think about it. When you consider the cost of an item, you usually think of its price tag. Costs can also apply to other things, such as the cost to society or the environment. Think of the bicycles that we use today. Do we need bicycles that have so many gears and special features? Or do we own something that has much more technology than most of us will ever use? We usually think of bicycles as being good for the environment since they don't produce pollution when they are being used. Of course, this is true. We should also consider, however, how a product is made and what happens to it when it is no longer needed. Designed for comfort. One of the features you might have evaluated in the previous investigation was the comfort of each bicycle seat. If you have ever attended a sporting event or a concert, you will know how uncomfortable some seats can be. The fans in the cartoon have found a way to make watching a sports event more comfortable. What do the cushions do to make sitting easier? How do inventors use their understanding of scientific concepts to design a more comfortable seat? The answer lies in the relationship between force, area, and pressure that you learned about in topic 4. Think about the difference between sleeping on the ground and sleeping on an air mattress. Why is an air mattress more comfortable? The science of comfort. When ergonomic researchers discover something that increases the comfort or efficiency of a particular item, technicians are quick to build, test, and market the changes. The testing systems shown above are designed to provide scientific information to researchers. This allows them to decide what type of safety belt or chair is the best for its designed purpose. Comfort is often something that is evaluated when a device is tested. Sometimes people must spend long periods of time in one position. Look at the wheelchairs on the right. How have the wheelchairs changed over time? Do earlier models look comfortable? Recent improvements in wheelchair design were made as a result of ergonomic research. Today, there are also many types of specialized wheelchairs. Thanks to advances in the design and comfort of wheelchairs, people who use wheelchairs are able to take part in sports such as basketball and track and field. Modifications in wheelchair design reflect how changes in society can produce changes in science and technology. Not long ago, for instance, people who use wheelchairs had limited access to many buildings and activities. Today, because people with disabilities have spoken out, and because society is much more concerned about the rights of people with disabilities, there have been many technological advances. Now we see wheelchair ramps, specially designed washrooms, doors that open automatically, hand-operated vehicles and bicycles, and many other technologies that give people in wheelchairs greater freedom. That's all, folks.